All right, so in this video, I want to look at finding a perpendicular bisector when you're given just two random points. And so I'm just going to program here two different points. Here's point A, and right now it's sitting at 1, 1, and then we'll just have a different point. Call that point C or D or whatever we want to call it. Let's give it a different color. And then I can just move this point wherever to a certain random spot. And let's make those into just nice whole numbers, although everything that I'm going to do in this video works regardless of if they're whole numbers or decimals. And let's make one of our a values negative, just to make it a little bit more interesting. Okay, so here we go. We've got we'll call this one point A on the left. We'll call this one point B on the right. And what I'm going to find is the equation that carves out the perpendicular bisector. And so when I see that word, or those two words really, perpendicular, that means that it's going to hit at a 90-degree angle. And bisector means it's going to hit it and cut the segment in half. So it's going to go exactly in between A and B. So a couple concepts should go into your head. When you hear perpendicular, that means that the slopes are opposite reciprocals. So it's not enough to just switch positive to negative. That's what the word opposite means. It's not enough to just switch rise and run. You need to do both of them to get perpendicular. So I'm going to do opposite reciprocal slopes, and then bisector. In order to cut the segment in half, I'm going to do the midpoint. So this is really putting together a lot of different concepts that we've worked on in bits and pieces, and now we're going to do them all in one problem. It doesn't matter if you find the slope part first or the midpoint part first. Those parts are independent. So let's just do slope first. If I want to find the slope, and I'm going to be really specific that this is the slope between A and B, because I'm going to have two different slopes, so I don't want to just use the letter M, because then I'll have two different M's in the problem. So I'm going to M of AB. I want to think about my rise over run. Some people like to just count it out. Other people like to use the formula y2 minus y1, x2 minus x1. So using the formula, thinking of B as my second point, 5 minus 1 over 6 minus negative 3. So be careful that the x value of A was negative. So this becomes 4 over 9. And you can see that if you draw that slope triangle, you're moving 9 boxes to the right and you're moving 4 boxes up. So 4 over 9. So to make a perpendicular slope, I need to do the opposite and the reciprocal of that. So I'm going to go perpendicular M, that upside down capital T, that's perpendicular. You can see it makes a right angle. So the perpendicular slope is opposite, so a positive slope changes to negative, and reciprocal, so 4 over 9 changes to 9 over 4. So what I want you to see now is a couple things. If I type in y equals 4 over 9x, 4 over 9x, you can see how that line is parallel to AB. And if I type in y equals negative 9 over 4x, you can see that line is perpendicular. They hit at a 90-degree angle. But one of the tricky things here is I actually want the line to be a perpendicular bisector to AB. So I'm going to delete those for now. I just wanted to show you that when we focused on just the slopes, we were able to get the slope of the line between A and B. So that's the purple line. And then the slope of the line that's perpendicular is the black line. All right, so let's get rid of those equations just to clean things up a little bit. Let's find the midpoint. A lot of people like to, again, sort of find the midpoint just by looking at it. You can kind of eyeball where the midpoint is, but you can also use a formula. I'm going to use a capital M for midpoint, and this is the midpoint of AB, so I'm just going to label it like that. Again, you can eyeball it or you can use the formula. The formula is you add the two x values and divide by 2, because you're finding the average, you're finding the middle. And same idea, you add the two y values and divide it by 2. So the midpoint of AB is going to be negative 3 plus 6 over 2. And then the y values added up is 5 plus 1 over 2. Make sure you do the plus on the top before you divide. So the first part becomes 3 divided by 2, 1.5. The second part becomes 6 divided by 2, which is 3. So if I type that in as a point, 1.5 comma 3, you can see that's right there in the middle of the other 2 points. So now I have everything I need to find the perpendicular bisector. I have a point and I have a slope. So I'm going to remind you, a lot of people, a lot of high school students, well, probably adults and children as well, a lot of people feel uncomfortable with point slope form. And they're like, oh, but I need it to be mx plus b. I want to remind you, point slope form is your friend. We're not teaching you point slope form to torture you. We're trying to teach you point slope form because it's easier to use. I don't want to necessarily figure out what the y-intercept is. I don't know if the y-intercept is a nice number or a nasty number. And these points that I chose in this problem are pretty small and pretty nice, but you will have problems that your points aren't small and aren't nice, and you just don't want to find the y-intercept. So using point slope form is actually nicer. All I need to do is copy and paste the y value from my point there, the x value right there, and the slope right there. And I have my equation. I can go y minus 3 equals negative 9 over 4, x minus 1.5. When you're using Desmos, it can handle it in point slope form. Y minus 3, negative 9 over 4, x minus 1.5. And you can see how that does go exactly through the midpoint and how it is going at a 90-degree angle to the other line. In fact, I can also write the point slope form of the line that connects A and B because I know that it goes through the point here. And let me clear my writing because now I have the equations written down here. I just used the point negative 3 comma 1. Notice that in my equation I wrote x plus 3. That's because I was subtracting a negative value right there. Okay, so you can see how I found the perpendicular bisector. Just 2 more comments before we're finished with this video. There was nothing special about point A. I could have used point B as well. I got an equally valid line using point B, subtracting the 6 comma 5 in the point slope form. Now, a lot of times in class and on like a standardized test or something, you don't have access to Desmos. You have to use one of the, graphing calculators, and those are created to only accept y equals formats. And so if you had to and you wanted to graph it, what you can do is add 3 to the other side, and you'll see that you get another equation that is equivalent. So this equation, y equals negative 9 over 4, x minus 1.5, and then just plus 3, that's also totally fine. Maybe you don't like parentheses. Okay, if you don't like parentheses, then just distribute negative 9 fourths x. And you got to think, okay, what is 9 fourths times 1.5? Well, 9 fourths times 1.5, you can do it on a calculator, or remember that 1.5 is 3 over 2, so we end up with 27 over 8. So if I'm working out here, that becomes plus 27 over 8, and then plus the 3 more, and that's another line that's equivalent. Okay, maybe you don't like having 2 separate fractions like that, so you can write it like negative 9 fourths x plus, think about how many eighths is 3. 3 times 8 is 24, so I have to add another 24, and I get 51 over 8. That's another line that's directly on there. And maybe you don't like fractions, you like decimals more, So 4 goes into 9 2 1/4 times. God, how many times does 8 go into 51? 6 point, is it 375? There you go. So I'm not telling you that you need to write out all of those equivalent equations. I'm trying to show you that any of those equations is equally correct, and they all describe the same line that is the perpendicular bisector of AB. So just to reiterate, perpendicular means you do opposite reciprocal slope. You switch positive to negative, and you switch rise and run. Bisector means it has to pass through the midpoint. The easiest way to write the equation is to start with point-slope form. If you have to make it into slope-intercept form, then you distribute the slope and you add the y value over to the other side and combine your like terms. So that's it. Please comment, ask questions if there's anything I can do to help. And thank you for watching.